Hello everyone, my name is Vinayak Datta Bharadwaj, roll number MEB 23018, and today I'm doing the Endterm assignment or examination of computer aided engineering ME 316, and I have got the question, and I have got this question, which is question number two of. Basically, it's a question of the modeling and finite element analysis of a torsional shaft with cross-sectional section as shown here, and it is and we are free to choose any relevant dimension of the torsional shaft as per our convenience. It is given that the shaft is fixed at one point, and the other point is subjected to a torsional movement. Now we will solve this using. I will be using two softwares. One is FreeCAD for the modeling part, and ANSYS for the analysis of the stress and various other things here. So here's the FreeCAD. Now we'll first draw the model of the shaft. We'll go to parametric body, and then we'll do a new sketch. We'll select any of the planes. Let us select the XY plane. Now we'll select the circle option with the center. We'll keep the radius. Let us keep the radius 15 mm. Done. And now we'll pair it up. Here is the pairing option. Let us keep the length of the shaft, the cylindrical shaft, to be 100 mm. Here it goes. So we have now completed the model making of the cylindrical shaft. Now let us save this file. Let us save it as Vinayak. Now we'll also export this file. Oh, we need to select the object first. Let us keep the name as Endterm examination and just Endterm. Let us keep it just Endterm, and we need to be careful while choosing the format. We need to keep the format in IGES format. So let's save it. Endterm. Yeah. Now I'll open the ANSYS workbench. So where it is. Now we will select the static structural option as it is not given in the question that which material to select. We will keep the material which as default, that is structural steel, and we can see the properties of structural steel here, which is a default setting. So where it is, just a second. So we'll keep the material to be structural steel, as it is not given in the question to which material, for which material to select. So we'll keep the material as the basic, the default, that is structural steel. So let us now do the analysis of it. So for geometry, we'll insert the geometry that the model we have made just now in FreeCAD. So we'll import the geometry here. We'll select browse. As you can see that the file that I had selected just a few minutes before was Endterm IGS, and we'll open it. It's there. Now we'll select the model option. It takes a bit of time. Yeah, here it is. So here's the shaft that we have just modeled it. Now for analysis purpose, we need to first mesh it up. For the finite element analysis, we need to mesh it up. Let us mesh. For this, we need to click the generate mesh. So yeah, you can see that the structure has been meshed. Okay, now we'll select the. Now we will fixed one end, as it is given in the question that the one end on the torsional shaft is fixed to a wall. So we will use the option of fixed support. Yeah, this will apply it, and yeah, as you can see that the right scene is the right mark is given here, has been that this the shaft has been fixed to an one end. Now we will have to apply torsion on one side of the shaft. For this, we need to go to the movement option here, and for the movement, we need to select here. We need to select apply. You, you have applied the movement option, and now we will select the magnitude to be 700 mm. Sorry, the magnitude of D will be 700 newton, so 700 Newton meter, not mm. We have select the magnitude to be 700 mm, and here it goes. The Yeah, there you can see that the movement has been applied as the right mark has come up. Now, yeah, I think it's done. The one end has been fixed. The other end we've applied the movement. Now we will select we'll select equivalent stress. We will also select the sorry. We will also select we will also select the the shear stress. We'll also see the uh, let us see this total deformation in it. And as yeah and we can also see the as it has not been given for what to find out. We will select only this the equivalent stress, the shear stress in it, and the total deformation of the torsional shaft. So let us now we will solve it. We'll select the solve option. It takes a bit of time, just a few seconds. Yeah, it's ready. As you can see that all these steps has been verified, or it's fully constrained. Now we can see, yeah, the equivalent stress here. Now you can see the animation of it. Yeah, as you can see that, and you can see the values here. And you can see that the values near the wall where the n has been fixed is very minimal, or yeah, it's not, it has been affected, to be precise. And the end where we have applied the torque, the movement, the maximum amount of the stress has been developed there. We can also see the shear stress. Yeah, you can see the animation where it is. The same goes for shear stress. For total deformation, you can see the effects of total deformation in it. Here it goes. The moment has been kept to be 700 Newton meter. The length we have selected to the 100 mm of the shaft, and the diameter we have the radius of the cylindrical shaft we have keep it to be 15 mm. So here it is. Now we have completed the question. So here it is. So thank you everyone.